So today's notes are about systems of equations. And today we're going to specifically look at how to solving them by, or today we're going to specifically look at solving them by graphing. Solving by graphing. All right. So for today, we're going to have two equations, and we're going to try to find the solution to the system of equations. And when we're talking about a system of equations, the solution is a point where the two equations intersect. And we can find that by graphing the two equations and looking for where the two equations intersect. However, there won't always be a point where the two equations intersect. Do you guys remember what it's called when two lines don't intersect? Parallel, right. So you could have a situation where you have two lines that intersect, in which case the point where they intersect is called the solution. You could have two lines that never intersect, and you could also have a situation where the two lines, once you graph them, end up being the exact same line. And there's specific names for each of these situations. This one here, there's a name for this, and I'm going to give it to you now. And we're going to talk about it a little bit more going forward in this unit, but I have to teach it to you. It doesn't get used that much more outside of Algebra 1. I'm going to tell you if these two lines will intersect once and they have one solution, it's called consistent and independent. And I like to think of it, so consistent means that they have a solution, and independent means that they're both like their own lines. They both have their own line lives that they go on to live in their own, like they have their own line friends that they go to see, but they just meet together for like this one line solution, but then they go on and lead their own line lives. Like they're their own line people, okay? They're line independent.
So they're in their own line world?
Yes. Well, no, like they're in the same line world, but like they get together for this line solution, and then they go on and they lead the rest of their line lives alone, independently. They're strong, independent lines. Okay? Okay, now this one here, if they don't touch at all, ever, if they're parallel lines, this is called inconsistent. Inconsistent means that there are no solutions. And then if you end up graphing them and they end up being the exact same line, they're consistent and dependent. Consistent and dependent. So unlike these other healthy lines down here that have their that live their own line lives, like these lines rely on each other to survive. Like these are lines that, like, if you were to make up a nickname about each other, it would be one of the ones where like you take the two names and like cut half of them off. Like it'd be like Brangelina, or like I don't know, what's a more current one, because that one's pretty old, especially since those two are getting divorced. I don't know. Like these two lines, like they can't live without each other.
They're like a couple.
Right. Like these two lines, well, not Taylor Swift, because Taylor Swift has like 1 million boyfriends. Like, sure. Taylor Swift is one of these lines over here. Like John Mayer is one of these lines. Taylor Swift is one of these lines. Like this line over here, where the two lines are the same, like this is a line that like it cannot live on its own. Like it has to have another line.
It's like high school kids, they have to date somebody to stay alive.
Sure, absolutely. Whereas over here, this is this line that's completely independent, this line is John Mayer. Like, John Mayer has never had a girlfriend for more than like 5 seconds. He's completely toxic. Okay? Alright.
Who's John Mayer?
Don't worry about it.
A person.
Okay. So let's take a look at an example here. Let's say that we have two lines. Y is equal to, let's do 2x plus 5. And let's do another one that's y is equal to 1/2 x plus 5. So with these two lines here, I want to find, first of all, I want to tell if they're consistent and independent, inconsistent, consistent and dependent, and then if they are consistent and independent, I want to find what the solution is. So the point where they intersect. I want to say what that point is if they intersect. If they don't intersect, I want to say that they don't intersect, and then just leave it at that. So I'm going to draw a super rough XY axis here on my paper. Now, do you guys remember how to graph plain old y equals mx plus b equations?
No.
Of course you don't. We covered it like 3 weeks ago. Why would you remember how to graph that? Okay, so I'm just gonna make my little. Now, I'm just gonna make my little.
Ariel Denny, please report to the office. Ariel Denny.
My little y-x-axis here. Now the steps for graphing here. The first thing you're gonna do. So I'm gonna deal with the first one here. First thing you're gonna do is you're going to find what your y-intercept is. In this case, it's b. I'm going to count to where my y-intercept is. It's plus 5, so does that mean I go up 5 or down 5 on the y-axis? So I'm going to count up 5 on the y-axis. 1, 2, 3, 4, 5. And that's where I'm going to make my first dot. Next, I'm going to look at what the slope of this line is. The slope of this line is 2. So what is the slope as a fraction for this line? So that means I'm going to go up 2, 1, let me make some more spaces for my slope. So that means from here I'm going to rise 2, run 1, make a dot, go back to where I started, and then also do what? Well, hold on. I went up 2 and right 1, and now I'm going to go down 2 and left 1, make a dot. And now I'm going to connect them. Now, because I'm trying to find out like line stuff, I'm actually going to want to have this line go as far as it possibly can inside my little box here. So I'm going to grab a super scientific tool, a ruler. I'm going to have my line take up as much space as it can inside my little box. So I'm going to use my ruler, not on your paper right now, no, because I did something tricky to this, which you'll see in just a second, but on your assignment you will, yes, which we'll talk about in just a second. Alright, so there's my first line, y equals 2x plus 5, graphed. Alright, now to graph my next line, to graph line number 2, y equals 1/2 x plus 5. So I'm going to go up 5, 1, 2, 3, 4, 5, that's where I'm going to make my first dot. My slope is 1/2. So from here, what do I need to do? Go up 1 and go 2 to the right, and then go back to where I started, down 1 and left 2. And now I'm going to connect it. Now, are these two lines consistent and independent, inconsistent, or consistent and dependent? They're consistent and independent, so I'm going to abbreviate that as C and I. Now, since they're consistent and independent and I have a solution, what is the point? What is the one point where the two intersect? Okay, I need to have an x comma y point. 0, comma 5. So x is 0 because I don't go left or right any, and y is 5. So it's 0, 5, right? Okay, I'll take that. Fair comment. All right, so let's take a look at today's assignment here. Yeah, I do. Well, I mean, you want me to have it. So, we're graphing today. Lots and lots of graphing. Yay! I know, I like graphing. I think it's good. I think it's kind of a nice break from what we were doing, in my opinion. Your miles may vary. Oh. Thank you. Your mileage may vary. You might not like it, which is fine if you don't. You don't have to like it. You can absolutely hate this. You think it's the worst thing we've done all week. Every new assignment we do, every new lesson we learn is an opportunity for you to hate it more than what we did the thing before. Which is honestly actually kind of good, because that's an opportunity for you to like what we did the day before more. Because if you hate the thing that we just did more, you're just still buying the thing we did the day before. Good? Yeah, yeah. Do you want this one instead? Okay. So, all right. So let's take a look at your assignment here. So question number 1. I specifically didn't put graphs on your assignment because I wanted you guys to get used to graphing on a separate sheet of paper.
There's a lot.
Because I mean, it's not that much. There's fewer than 20 problems on your assignment.
There's 18.
Right. Fewer than 20. Okay, so let's take a look here. Question number 1. So you've got the 2 graphs here. So I'm going to put my piece of graph paper right next to it. And y equals negative x plus 4, and then y equals x plus 2. So first of all, if there's no number in front of x, what number is really there? 1. So let's graph the first one here. So if it's y equals negative x plus 4, where do you need to start out at? Hold on. No, so you're going to start out up 4 from 0, right? So I'm going to count up 4. 1, 2, 3, 4. And that's where I'm going to make my first dot, is up 4. Now from there, my slope is negative 1. So since the slope is negative 1, from there, where should I go? So if I go down, I shouldn't also go left. I should go down and right, or up and left. So there's the first line. Now, if you need to use rulers are found in a drawer marked rulers next to Michael. So that's where the rulers are. Do we need to do the whole, Elijah? Do we need to do the whole what are rulers and what are rulers not lesson? Okay. Because they're not lightsabers, they're not flippy floppies. I've never once claimed they're unbreakable, so don't try to see if they're unbreakable. Right?
Yeah, you'll break it.
No, I don't want you to try. Okay, so the next one is y equals x plus 2. So where do I start out at? I go up 2. And then what's the slope of this line? So what's the number in front of x?
1.
Okay. So that means my slope is 1. So I go up 1 and
Up one and left one.
no.
The right one.
Up 1 and right 1. Or down 1, left 1. And then when I connect these, now are these two consistent and independent, consistent and dependent, or inconsistent? So over here on my piece of paper, I'm going to do C and I. Or you can write out the whole words if you want to. And then I'm also going to say what the point where they intersect is. So where do they intersect?
1.
Okay, so they intersect at the point 1, 3. Now if they didn't intersect, if they were parallel, I would write inconsistent. And if for some reason they graphed to be the exact same line, I would write consistent and dependent, or C and D.
You wouldn't have to write a point.
And you wouldn't have to write a point because it would be every single point, because they'd be the like right on top of each other. There'd be no room for error. Okay? Mr. Taft would be behind them in the hallway being like, don't hold hands. Okay? So, let's take a look at the next one here. So, number 2. That's number 1. Negative 2x plus 4. So I'm going to mark where my origin is just to give myself some bearings. Negative 2x plus 4. So where do I go first? So I'm going to go up 4, right? 1, 2, 3, 4. And then the slope is negative 2x. So negative 2 is the slope. Down 2 and right 1. And then I'm going to go back to where I started and do the opposite of that, which is up 2 and left 1. I'm going to use my ruler and take up the space that I'm given, just so that I can, like, just in case the intersection ends up being like somewhere down here. Okay? So next is y equals negative 1/4 x minus 3. So where do I start for that minus 3? Down 3. Yep, so I go down 3. 1, 2, 3. And then negative 1/4 for the slope means what? Down 1 and right 4. So down 1, right 4. Or up 1 and left 4. So then are these two C and I, D, or C and D? Or sorry, C and I, or C and D? They're C and I. And then what's the point where they intersect?
4, negative
4, negative 4. All right. Cool. So you guys can work together if you want to. I'm going to give you guys probably some time to work on this in class tomorrow. Yeah, since we're starting so late, I won't give you a ton of time, but I'll give you some.